Hey everyone, this is Dr. Walker. This is video 8C, Graphical Interpretation of Velocity. Whenever there's a C after the video number, that just means that there is some calculus involved in the video. Let's look at graphs. So how can we get information about velocity from looking at a graph? What we're going to be looking at is a position time graph. This means that the y-axis is position and the x-axis is time. Whenever you're given the name of a graph, it's always y versus x. So that's how you know what is plotted on which axis. If we look at this line here, it represents the displacement of the object. The object starts at negative 20 meters, then takes 10 seconds to go up to 0 meters, then takes another 20 seconds to go up to 40 meters. If we look at the curve, we see that it is a straight line. The slope of this line gives us the average velocity. This makes sense because average velocity is defined as change in x over change in time. So change in x is rise, and then change in time is the run. So rise over run is slope. What we also notice from this graph is that it's a straight line and that this indicates a constant velocity. We can see this because we see that the object travels 20 meters in 10 seconds, then another 20 meters in another 10 seconds. So whenever you have a straight line, that's a constant slope, that's a constant velocity. Let's look at this your turn. Go ahead and pause the video so you can think about it. The question asks, which graph shows the fastest leftward velocity? Let's see what we can eliminate. We just said that the slope of the line gives us the average velocity. So the higher the slope, the higher the velocity. And a high slope means a steep line. So we can already eliminate the two lines that are not very steep. Now we have one line that has a positive velocity, and down here, one line that has a negative velocity. A positive, and sorry, I meant slope. Positive slope, what that means a positive velocity, right? And this one has a negative slope, and so that means a negative velocity. If we want leftward velocity, then that implies a negative velocity. So the choice is this one. Remember that if we have motion to the right, it's considered positive. Motion to the left, it's considered negative. You can see in this bottom right graph here that the position goes from a high number down to the origin. So maybe the position goes from here to here, so that means we're moving to the left. What about if we have a position time graph, but we have a curve? So first of all, what the curve means is that you have a non-constant velocity. You can still find the average velocity between 2 points by finding the slope of the line connecting those 2 points. For instance, from points A to B here, we have moved a distance delta x here from about 30 to 50, so about 20 meters up, and then we have moved about 10 seconds. So we can still find the slope of this blue line here to find an average velocity between the 2 points. But the velocity is not constant because the slope keeps changing. We can see we have a steep velocity, which means a high velocity, and then as it is less steep, then the velocity is decreasing. The next thing I want to talk about with these position time graphs is instantaneous velocity. We learned about instantaneous speed in the previous video. Instantaneous velocity is very similar. It's your velocity at any instant in time. So the definition for the instantaneous velocity is going to be the limit as delta t approaches 0 of delta x over delta t. We know delta x over delta t is average velocity, but if the time interval approaches 0, that means that instead of looking, for instance, from points A to B from here and getting the average velocity between those 2 points, if the time interval approaches 0, that means that now we're looking for the velocity from here to here, or when it approaches 0, the instantaneous velocity at that point. So that is going to be the derivative, dx dt, derivative of x with respect to t. So if you have a curve and you want to find the instantaneous velocity at any point, then at that point, you would have to draw a line that is tangent to the curve. Tangent means touching. So I just drew a tangent line at point B here, and the green line was the tangent line at point A. So find a slope of that tangent line. That gives you the instantaneous velocity for that particular time. In the next video, we will do some examples.